As said in the previous video, we are going to solve the correlation that Hagen proposed. The program logic is very simple. If the velocity through the pipe is less than 1.1 feet per second, we will use the formula pressure drop is equal to alpha times velocity. Else, the pressure drop will be equal to alpha times velocity raised to the power 1.75. We will use the if condition and the for loop to accomplish this. We will also go over some new plotting options and learn how to save a plot. Okay, we start with the usual lines clear all, close all and CLC. Next, we create variables for density and dynamic viscosity. It is a good practice to write down the units as comments for future reference. We will now create a variable called velocity ft to store the values of velocity in feet per second. I'm using the linspace command to generate values for velocity. The linspace command generates an array based on 3 inputs. For example, if you need to create an array which starts from 2 and ends in 5 with 10 values between them, you should type linspace of 2, 5, 10. In the same way, I'm varying the velocity from 0 to 2.5 feet per second with 100 values in between them. I then create a variable called velocity which contains the velocity values in meter per second. Note that I'm using the element-wise operator and a conversion factor of 0.3328 to convert feet to meters. The variable d refers to the diameter of the pipe and the variable v underscore crit refers to the critical velocity, which is 1.1 feet per second. Finally, I define a constant called alpha. Okay, now let us calculate some useful parameters with these newly defined variables. First, we calculate the Reynolds number for each value of velocity. Note that since velocity is an array, the output of this operation is also going to be an array. Next, we calculate the critical Reynolds number based on the critical velocity. Note the factor 0.3328 appears here to convert the velocity to meter per second. We use a for loop to loop through the entire velocity ft array. Here is an example to demonstrate how a for loop works.
In this example, we will learn how to use the for loop. Loops in general are used to repeat a set of instructions. In the for loop, we have a loop counter variable, which in this case is I. We specify the start and end values of the loop counter variable, and the loop counter variable increments itself by 1 automatically. As a next step, we set the end value of the loop counter variable to be equal to the length of an array, and finally do a simple operation involving the contents of the array x.
As we discussed earlier, if the velocity is less than the critical velocity, the pressure drop is just alpha times the velocity. And if the velocity is greater than or equal to the critical velocity, we multiply alpha with velocity raised to the power 1.75. The if statement should terminate with the keyword end. Finally, we are ready to do some plots. We are going to plot the critical velocity and the corresponding pressure drop first. Next, we use the plot yy function to make the main plot. The reason why we choose this function is because we want to make use of the y-axis on the left hand side and as well as on the right hand side. First, we plot the pressure drop versus velocity. Here, pressure drop will be shown on the left-hand axis, and we are also going to plot Reynolds number as a function of velocity. And since we are using the plot yy command, the Reynolds number is going to be shown on the right-hand side y-axis. The plot function gives 3 outputs. Ax refers to the axis of the plot, h1 and h2 refers to the blue and green curves. Altogether, Ax, h1 and h2 are referred to as handles. If you want a better understanding about handles, read the documentation. Okay, going back to the code, as an exercise, try to figure out what the set command does. Finally, we assign labels to the x and y axis. Since we have two y-axis variables, we will use the handles ax of 1 to refer to the left hand axis and AX of 2 to refer to the right hand side. You can modify the font size of the text using the font size attribute. As a last step, I save the plot as a JPEG file in my desktop using the save as command. You will notice that I pass a parameter called GCA to the save as command. Here, GCA is the handle to the active plot.